Okay, well, yeah, thank you for the opportunity to talk about money spiders. I don't think there's too many courses on money spiders online. They're a little bit unusual, but I'm going to try and give you a nice overview of money spiders. I'm going to focus on a few common British species and throw in a few rarities as well, because people always like to see rarities, and give you a few ideas of where to find them. So the first part of the course, what I'm going to do is just go through what is a money spider, how to start getting into the identification of money spiders. And I'm going to take you on a bit of a guided tour of different habitats and which species of money spider you can find in those habitats. So I thought it'd be a bit easier doing it that way rather than throwing lots of random species at you and just said, this is this, this is this, this is this. So we'll do it that way. Right. Okay, so I'm Richard Gallard. I'm a member of the British Arachnological Society and I'm on the council. We're quite a well-established society in the UK and we study British spiders ostensibly. We've also got a recording scheme, spider recording scheme, and that's a fantastic resource if you get the opportunity to go on the website there. You can find it by Googling. And it's got all the maps of all the British species and bits about the ecology, so you can certainly follow up any information you want there on that site. Right. Okay, so I'm assuming that not everybody's an arachnologist who's on this course, but I guess a fair few of you are, so just bear with me. What I'll do, I'll take people through the basics of spider anatomy so you know what I'm talking about. So there's a typical large money spider. So the head bit is the carapace, that's that shield-shaped area on top of the body, dark brown in this case. Then you've got the abdomen, that's the squishy bit. So essentially a spider it's an arthropod. So it's got a suit of armor. So all the leg segments, the head and so on. It's like the exoskeleton, it's chitinous and very strong and not very flexible. But the abdomen's different. You can think of that as like a balloon. So it can expand and contract depending on how well fed the spider is. If it's dehydrated, it can contract. If it's gravid, it can swell. So bear that in mind when you're looking at colour patterns, because that can radically change depending on how well fed the spider is. Then we've got the legs. So the convention is that we name the legs from 1 to 4, front to back. So if people hear the term, look at leg 1, well, that's the front leg. Leg 4, that's the rear leg, the back leg. Then you've got these two little leg-like segments at the front there, and they're called palps. They're quite important for spider reproduction, so I'll go into that later. Eyes, generally at the front of the carapace. Not too clear in that image, but you'll see them in some of the other images I give later. Show you maybe more structured. Most spiders have got 8 eyes. Some have got 6. There's a few sort of cave-dwelling ones that have reduced eyes. I think most British cave ones still have 8, but they're really reduced things. Leg segments, you're probably familiar with these terms. So the big bit down at the base is the femur, the patella, the knee, the tibia, shin, and then metatarsus and tarsus. So tarsus is the foot. So it's quite important to know where the tibia and the metatarsus is, because we'll be using those leg segments for identification. So bear that in mind. Okay, so flip the spider over and you can see different features that you'll be looking at. So this shield-shaped area between the legs is the sternum. So pretty similar to the terminology on a human, really. Chelicerae, these are these movable mouth parts which the fang is attached to, and they can articulate up and down and massacate the food or deliver the venomous bite through the fang. And then obviously the abdomen, and then the spinnerets, these are like little digitiform appendages on the tip of the abdomen, and from that they extrude the silk to make the webs and produce the egg sacs. And then the epigyne. So in female spiders, well, most female spiders have this epigyne structure. It's a sort of sclerotized, very distinctly shaped entity. It's essentially the opening to the female reproductive system. So I'll talk about that later. And obviously legs, palps, you've seen them before. So I didn't mention these lower limb segments. So the coxa is the first segment. And then the trochanter is this tiny little segment there on the legs. So you don't tend to see them from the dorsal surface, only from the ventral surface. Right. What is a money spider? That's actually quite a difficult question to answer, really. And the cop-out answer is they're all in the family Linyphiidae, but that's just essentially saying a money spider is a money spider, isn't it? So they've got a few general characteristics that you can use to define them. I would say that this talk is focused on British material, so this may not apply to sort of afrotropical montane linyphiids and so on and so forth. Right, so they're generally small. We're talking about something in the range of 1 millimetre through to about 8 millimetres, and a lot of them are towards that lower end. So essentially, if it's small and mature, it probably is a money spider in Britain. So that's quite a handy thing. Most of them make these sheet webs. I'll show you some pictures later. And essentially, it's like a trampoline of silk. They hang on the underside and run on the underside of this sheet. And the little webs are tiny. They're not huge, expansive things in the main. This is probably a more useful taxonomic feature. The males have got this structure called a Paracymbium. I'll show you that later. Some other families of spiders also have it, but it's quite a useful thing to knock out a few of the other families of spiders, so do bear that one in mind. There's also have these stridulation ridges on the outside of the mouth parts. So stridulation, they can rub against the different structures to make little noises and what have you. And they'll do that during courtship. And the nice thing about a lot of money spiders is some of the males have these highly modified head structures, which they're really bizarre and funky things, really. You look at them down a microscope and you just can't imagine why that's the case. And I've got some good pictures of these later on, and I'll sort of explore why they have some of these modifications. Right. Problem with money spiders, there's quite a lot of them. So they make up 42% of the British spider fauna. And we don't have a huge British spider fauna, it's 673, but 42% of them are money spiders. So realistically, if you're going to get into spiders, you need to consider money spiders because there's a significant proportion of the British fauna. And 1, 2, 3 genera, that's easy to remember. So that's probably what makes them a bit difficult to think about and difficult to get into, because you do have quite a lot of species to work through to separate them. They're not a nice tight group, really, but I'm going to show you that some of them are dead easy to identify. They're not all really tricky things. Right, so there's just a graphic just to show the importance of money spiders in the British fauna. So a lot of people that start out working with spiders won't even touch money spiders. They say, oh no, they're too difficult, don't want to know. But you can see you've really got to look at them if you want to get a good ecological feel of the number of spiders in the habitat there. Right, so I mentioned the sheet web. Well, this is actually one of our larger money spiders. This is a classic sheet web. It's got these intersection lines here, so an insect will blunder into these and then fall onto the sheet, and then the spider's somewhere in this bush and it will run out and then grab the prey on the trampoline. This one's Linyphia triangularis. So they mature about late August, September time. So if you go out on a dewy morning and see these garden bushes just festooned with these webs, chances are it'll be Linyphia triangularis. It's an extremely common spider, quite large for a money spider. We're sort of getting 6 millimeters area and quite nicely marked. So strange thing, you can't find them at this time of the year. they're very autumnal species, so there'll be little immatures at the moment, or just hatching from egg sacs, presumably. So that seasonality with spiders is quite important, because you can go to a site early in the spring or late in the autumn, and you'll get totally different species. There'll be some that will be common to both seasons, but you need to visit sites multiple times to get a full appreciation of what's on there. Okay, that Paracymbium I was telling you about, it's this structure I've highlighted in red. It's like a plate, I suppose. It's there in the real spider. And generally it has this sort of boss on it. So they can be sort of J-shaped or what have you. But pretty much all Linyphiidae have got this in one form or another. So if you're looking at a palp, this is the male palpal bulb area. You look for this Paracymbium, you can be fairly sure if it's a small spider, you've got a money spider. Now, these palps are quite important in male spiders because they're what they transfer the sperm to the female in, but they don't actually produce the sperm in these palps. Their palps are sort of effectively like pipette eyedroppers. So the male spider will deposit sperm on a sperm web, drop a sperm on the web, and then he'll dip these palps repeatedly into this drop of sperm and charge the palps up. So that's the embolus. So that's the actual structure that is inserted into the epigyne, into the female reproductive system, and then the sperm is then squeezed through this channel. So it's like there's like a reservoir of sperm that it's taken up in there. But it doesn't mate in this form. So lots of these structures are like a balloon. So some of them are hardened like this. This is probably a conductor. Paracymbium, that's sort of rigid. But it's all actually attached to like a balloon, like a bag. So it inflates with hemolymph. And it's a totally different structure. So it sort of folds out in a complicated structure. And only then does it engage into the epigyne for mating. So this is essentially the collapsed form of it. And that's quite important when you're doing pitfall work, because when you're doing pitfall trapping, occasionally these palps will expand into the shape that it takes on when it's full of hemolymph for mating. And it won't look like anything that's illustrated in a book. So it makes it quite difficult. You've always got to make sure your palps are in this uncollapsed form before you even start trying to identify a spider. You can reverse it slightly if you've got some in pitfalls by adding a bit of salt to the solution, and it will dehydrate the spider and the palp will collapse back into its relaxed form. So yeah, good tip there really if you're struggling with some of this pitfall material. Right, those stridulating ridges I was telling you about, they're quite interesting. They're clues in the name. They're essentially little ridges. So if I flick flat, you'll see them on the outside face of the chelicerae. And what they'll be doing is engaging with a peg or another structure on the inside of that leg. And it rasps against it like a sort of fingernail along a comb. And it makes a little noise or sort of a rasping sound, I suppose. Obviously, we can't hear it. It's just too faint for our ears. But that's what they use during courtship. There's very complicated courtship rituals that allow species recognition going on there. So quite a nice feature. Difficult to photograph, actually. So it's quite good. Right. These modified heads I was telling you about. Well, they don't get more modified than this one. This is Vulcanaria acuminata, and the eyes are effectively on a periscope. So there's an eye there, there's an eye there, an eye there. So in most normal spiders, the eyes are down here. But bear in mind, a lot of money spiders are on webs hanging upside down, so they have a slightly different outlook. And these are the palps. You can see how complicated the structures are here. And these modified heads are very peculiar and species specific by and large, but not all money spider males have modified heads. So very useful for identification. So in this species in Britain, if you find a spider that looks like this, it's definitely Falconaria acuminata. You don't even have to look at the palps or anything. There's nothing else that looks like it. Now, in the Mediterranean, you might have to look at the palps because there are sibling species out there. Right, Trichopterna thorelli. You can see this is another small money spider with modified heads. Well, what are these modified heads about? Well, they're actually about nuptial feeding in courtship. So here's a pair of money spiders courting. So this is the big female on the left, and this is the male with his modified heads. And you can see how the female chelicerae and the fang, they sort of engage into that complicated head structure. And then the male is reaching underneath with his palps to inseminate the female. But more strangely than that, they're actually producing, the male head has got glands in it, and it's producing a substance, it's a liquid that the female is eating. And that's quite crucial during the mating ritual in some of these spiders. So there's a lot going on, and they're not necessarily mating at this point. It's sort of pre-mating, really. And it gets more complicated than that. So there are some species where some males, mature males, have got this complicated head structure. So this is essentially a hole in the head with lots of bristles. Yet that's another adult male of the same species. It doesn't have this structure, but they're both the same species, and they both occur in the population. Now, there's some Belgian scientists who've done some work on these, and they found that the genes that control this are dominant. The genes that control this are the recessive ones. So this, in theory, should be the common version that you see kicking around, and this is quite rare, but actually it's relatively common in North Wales. I find more of this form than that. Now, they've sort of speculated that the reason for this is that this form, the modified head, this can produce the glandular secretions. So female that's already mated will be more likely to mate with this male, simply because she gets something out of it. She gets a feed. So if she's already mated, she's likely to mate with this, and the male will then replace the sperm from a previous mating in that female's spermatheca, the sperm storage organ. Whereas this form supposedly matures quicker because it's less complicated. So that'll coincide with when there's females that haven't been mated. They're more eager to mate, so they don't necessarily favour males that are providing a food source from the head. So quite unusual things going on there, and lots of interesting research to look into. I just find that fascinating that you can see two things that you'd think, oh, they've got to be different species. They're so radically different, but they're not. They're the same thing. So you can't actually separate the females based on the genetics. You'd have to go into gene sequencing to find that out. But yeah, fascinating that that's actually kept in the population. Right. So I said that money spiders identification is a bit tricky. So you've got 285 spider species to consider when you've got a money spider in front of you in Britain. So you've got to start reducing your options, really. It's like any species identification. You've got to make it easier for yourself. So how do you do that? Well, because they're small, you've got to use a stereo microscope to identify them. And the range at most sort of entry-level stereo microscopes are ×10 up to ×40 now. ×20, ×40 will generally allow you to identify most money spiders. You could ideally go up to ×90, but really you're losing so much depth of field that the gain is not worth it. So that's the sort of equipment that you need to start working with them. And I say this all the time, spider identification, it's no more difficult than playing spot the difference, really. You're going to the reference books and you're looking at illustrations and you're going, no, it's not that one, might be that one, definitely not that one. And then you sort of then honing in and go, oh yes, it's got to be that one. So don't get too tied up about working slavishly through keys with spider ID. There's no right way of doing spider ID. If you can bypass keys and go straight to the illustration, that's good enough. You've got a nice concrete identification. Right. A good thing about money spiders is you can split them into two major groups, and that effectively splits the work in half for you. So what you want to do is put them into the right subfamily. So the bigger money spiders tend to be more patterned. They'll have an abdominal pattern and often annulated legs, but the smaller money spiders are usually unicolorous, very small squat legs, generally dark. These are the things that you get ballooning, sort of landing on you when you're walking in the countryside. These things are the things that you'll find living on the underside of big sheet webs. So you split them by whether they've got how many dorsal spines on tibia 4, the rear tibia. So if they've got 2 dorsal spines, they're in this subfamily. If they've only got 1, they're in the Erigoninae. So that's useful because in the Roberts book, they split quite well in the book. So from anything past Erigone, the genus, will be in this group, sorry, and anything before will be in that group. So you don't have to go through quite a lot of pages if you've already worked that out. Right, so another thing is you've got to be able to recognise what are these different things, spines, setae or Trichobothria. And they're all quite important for getting to know your spiders, money spiders. So this is a very close-up version. So there we've got the spines. They're generally the thickest hair, for want of a better word. They are actually articulated, but once they're preserved, they're pretty much static. So once they're preserved in alcohol, they're not going to be moving around. And they tend to stick up quite prominently. They're obviously a lot thicker. You can see they've got a bit of a pit that they're in. And you'll get to recognise them the more specimens you see. Now the next thing are these setae. Well, they're essentially like spines, but they're more numerous and they tend to be inclined. So you'll see these lower things. These are the setae. Now you don't necessarily use these in identification of setae, but you can mistake them for the more critical spines and Trichobothria. So it's good practice to get to know what they are, so you can disregard them really. So yeah, setae lay an incline, spines tend to stick upwards. Which is not going to work. Trichobothria, or Trichobothrium. This ultra fine hair, and it sticks up a long way past the setae, but it's also mobile. And it's mobile even in preserved material, so it'll waft about like this under the microscope. So what you can do is put your forceps near the leg, under it, and you can look for any hair that moves. And if it moves, it'll be a Trichobothria. And there it is. So extremely fine thing. It's in this little, almost like a ball and socket pit, which allows it to rotate around. And they're sensory hairs. Move around on the slightest draft of wind. They're sensitive to electrical forces, which is quite important for ballooning spiders too. So very useful to know. And that's critical to know how to find these Trichobothria. They can be really difficult to find, but you do need them to separate down to genus. Okay, there's a more grainy picture, but it does show you just how long the Trichobothrium can be. And usually they're in a bit of a darkened pit, and on the upper surface of the metatarsus, they're the ones that you're interested in. Right. Apologies for this slide. It looks more complicated than it actually is. So this is just consolidating exactly the features you need to know to identify your genus of money spiders. So with the Trichobothria, all you need to know is its position on leg 1 metatarsus. So it'll generally fall into one of these 4 areas. So if it's in the middle, you'd code it as 0.5, so 50% halfway down the segment. Similarly, if it's 2/3 the way down, 0.6. If it's near the end of the metatarsus, 0.9-ish. If it's 1/3 the way down, 0.3. And you can slavishly measure these with an eyepiece graticule, but to be honest with you, you don't have to be that accurate, really. It's whether it falls in these 4 categories, and that will help you. It will certainly knock out a few genera that you don't need to consider. So that's what I'd recommend you do. Now, dorsal spines, naturally they're on the top surface. They generally, where's my mouse? They generally sit along the midline. So if you're looking at the leg segment, the tibia from above, they're on the midline, but they can be slightly offset. So be careful with these lateral spines. So you'll get retrolateral and prolateral spines that you might mistake for these dorsal spines. So you just watch out for that. And that'll help you obviously get to those subfamilies, knowing whether it's got 1 or 2 dorsal spines on tibia 4. Right, so drawings are all fair and good, but actually trying to interpret it on a natural spider is sometimes more tricky than it looks. So prolateral, essentially that's at the side, facing forward, so pro, forward. Retrolateral, on the side, facing backwards, retro. So fair and good. Some of the keys, like for Paroma, they do mention these, Agonita, useful to know those terms really. But the dorsal ones can be a little bit misleading. So this one looks like it's sticking out towards the back. So you might mistake it for a retrolateral, but if you look where it's actually connected to the tibia, it's actually on the dorsal surface. So there's 1, there's 2. So if that was leg 4, you'd know instantly that there's 2 dorsal spines, so it's in that Linyphiinae subfamily. Likewise, you just got to manipulate your spider into the correct plane of view to see these. So often the dorsal spines are easier to see if you're looking at them from the side because they're sticking up like this. Right. Okay, so some real world examples. Well, here's a classic Erigone. I can never say these words. Erigoninae. So you'll see 1 dorsal spine on the rear tibia, really obvious. There's definitely not another one there. So you're happy you know the subfamily. Unpatterned abdomen. Yeah, that ticks the box. Relatively short, stubby legs. Yeah. And a lot of these, they're either dark like this or they've got reddish legs, but they've never got these really ornate patterns on, or exceedingly rarely. There's 1 or 2 that do, but most of the ones that you're going to come across are like this. They're unicolorous, really. Contrast that with the Linyphiinae. You'll see instantly this is a much more leggy animal. The spines tend to be more prominent and more numerous, actually. And you'll see this nice chevron marking. They generally have types of chevrons or mottling markings. So some of that can be obvious even using a hand lens. And there you go, you've got your dorsal spine there. 1, 2, 1, 2. So yeah, happy with that subfamily. And you'll actually get to know these just by sight, just by the look of the spider. If it's got these long gangly legs and an abdominal pattern, you'll know instantly it's in that subfamily. So that stops you having to go through remembering the keys all the time. You see these prolateral spines here quite obviously. Okay. So what you're doing, you're using that the location of the spines, the location of the Trichobothria to get to your genus. And then what you're doing is matching those palps and the epigyne with published illustrations or photographs to then identify your species. So this is a table of the information that you need to gather from your specimen if you want to work out what it is. So this is all you need to know. So metatarsus 1, Trichobothria. So they're termed TM. So Trichobothria on metatarsus, leg 1. And that ratio, so you'd write that down. So in this case, it would be in the middle, the metatarsus, so 0.5. Then on the rear leg, is it present or absent? You don't even have to know the position, really. You just want to know, is it there or isn't it? Now, it's worth checking both sides because occasionally they do break off. So it doesn't take too long just to look at the opposite side to see if it's still there. So particularly if it's absent, you want to make sure it is absent. It's not always easy to see the hole that it used to be in, so don't assume it's absent. Just check both sides. It could be absent on one, broken off, present on the other. And then just go through the dorsal spines on the tibia. So we code it like this. So you'll see in some of the books they code it, and some of the web resources. So they're usually in this sort of form where you get 1 on the front, leg 2, 1, leg 3, 2, so on. So you're not going to be getting 4s, 5s, 6s. It's usually 1, 2, so on. Then you go to your published tables. So there's various tables available. There's even some interactive online resources which have been developed. I don't think they're available at the moment. They were on the TomBio system, but I think there's talk of that being re-established at some point, so look out for that. I think Rich Burtmar developed this with Nigel Kane-Honeysett. So this is quite an old table that uses some of the old-fashioned genera, the older names, but you can see it's got a table showing you the range for Trichobothrium metatarsus 1, the tibial spine notation, also the size range. You might want to make a note of that. I don't find that particularly useful. And a few interesting key points that you might make a note of, i.e., is it a red and black one, or is it an entirely black one, or is it a pallid species? And all you're doing is going down these tables and then narrowing your options, really. So if you had that form, you just look down this table until you found the entries in that table that match your specimen. And it'll often throw up 2 or 3 genera that it's likely to be in. And then all you're doing is going to the book, looking at the epigyne or palp illustrations for those 3 genera, and then going, oh, is it one of those 3? And chances are it's going to be obvious which of those it is. Now, some of them are a bit more tricky, but that's how it works, really. It's quite straightforward. It's sort of a mix of a tabular key and playing spot the difference, really, getting to know money spiders. And eventually you'll find that you familiarise yourself with the epigyne and palp, and you'll just be able to go straight to it in the book because you've seen it so many times. You won't have to go through this rigmarole of measuring Trichobothria and spines and what have you. But obviously when you first starting, you need to do your homework to get familiar with what these things look like. And then obviously go to your preferred reference book. The 2 British references that you'll use is either Lockett and Millage. That's the old book that was from the 1950s. This is a 1970s reprint. I think it's still in print, actually. I think you can still get it. Quite good. It's got all the illustrations in there. So there's everybody's favourite, the piranhas. probably the more useful book, the illustrations of CRISPR certainly, is the Roberts. So you can see absolutely superb illustrations of all the British species. There's obviously some of the more recently found species aren't in there. You'll have to search for those illustrations online, but they are quite expensive books to get. But if you're going to do an idea of money spiders, they're the ones you're going to need. If you're just getting into spiders and just want a photographic guide, this is a fantastic one to get. It's Wild Guides. It doesn't cover money spiders in a great deal, but it does do some of the bigger, more obvious species that you're going to come across. So that's worthwhile if you're just very new to spiders. Right, so survey kit. That's always nice to talk about survey kit. So I thought rather than go through each bit individually, I'll have it all on a one screen. So this is what I use. So a beating tray, it could be as simple as an upturned umbrella and a stick. So all you're doing is whacking a bush, putting the beating tray under it, looking for what falls out of the gorse bush or what have you, and selecting what you want to keep. Sweep net, essentially a net with a very thick calico bag or what have you. You're swishing it in a figure of 8 through long grass and then inspecting what you find. You'll see a lot of my kit's all cobbled together from bits of rubbish. So that's one of those military tarps that you can buy in army surplus stores, and it's actually better than some of the cloth beating trays because it's waterproof. So you're thwacking a gorse bush and all the water's raining out if it's just rain, but you can just wipe this in the grass and it doesn't turn into a sodden, saturated mess. And that's a bit of plastic pipe, you know, the sort of water mains pipe. Very good because you can hit branches and it doesn't damage them too much, whereas if you were using a metal pole, you'd smash the vegetation to pieces, and I'm sure reserve managers aren't keen on you doing that. So that's a bit, and it's lighter to carry as well. Variety of sample tubes, so some of those have got IMS in, industrial methylated spirits for preservation. Some are dry tubes, so you might want to take some specimens home for photography or what have you. GPS, just to get your grid reference for your record. And one of these cheap garden sieves, brilliant for getting sphagnum moss, leaf litter, sieving it over a tray and finding what drops out. And then you can get these polypropylene trays. I think they sell them on eBay for crafting, sort of scrapbook, sort of keeping bits of paper in and what have you. And they're ideal because they're nice and light. You can hold them up and it's sort of translucent and lightweight, easy to carry. And strangely enough, it actually fits that sieve pretty well. And thick rubber gloves, very useful for messing around in vegetation at ground level. You'll appreciate that if you ever come across certain items. And a vacuum sampler. Now, this is the revolutionary bit of kit that pretty much everybody who's really into surveying spiders uses now. So all it is, they're often described as modified leaf blowers. Well, not that modified. If modification just means putting a net in the nozzle and attaching it with some Jubilee clips, that's all you're doing. So that's the inlet nozzle that would take the leaves in. That's the exhaust nozzle. So you don't need the bag that collects the leaves. All you're doing is putting that net that's in there into deep in the vegetation, and it's sucking up any loose vegetation and also invertebrates. And then you can empty that bag of its contents through this sieve onto the tray. And that way you're getting rid of most of the brash, and then you can pick out the spiders you're interested in. Now, these two-stroke machines are great, really powerful, but they're heavy. They're a bit of a pain to use, actually, so the exhaust fumes. And a lot of people are now moving over to these electric battery-powered jobs. So little lithium-ion battery pops in, lasts a good length of time. Product placement there. I think there is only this one really that you can use. You can see all I've done is attach a sort of entomological bag onto the inlet nozzle, a couple of these big Jubilee clips, and this is also a rim protector. So you can buy this. It's what they put on the edge of car doors and what have you. You can buy it by the meter, and that just stops it wearing away the net as you're jabbing that nozzle into the vegetation. So that's really lightweight. I think it's about 4 kilograms. You can pop it in the back of your rucksack and away you go. And it's revolutionized spider sampling, actually. You're turning up things that you would spend hours on your hands and knees groveling to find, whereas that thing will just turn up hundreds of specimens in a few minutes. And brilliant for other entomological use as well. So I thoroughly recommend you getting that. And then, because spiders are small and delicate, you need something called a pooter to pick them up. So all a pooter is 2 bits of tubing, with a bit of mesh, a bit of tights or something like that, and then some gaffer tape. So you push them to 2 different size tubes together. What I've found that's useful is if you use this silicone tubing, which is a larger bore, with a sucking end, it's always flexible, even in cold weather. Now the PVC tube, which is the tubing you often get for fish tank air pumps, that actually stiffens quite a lot in winter. So you'll find it almost unusable in December. But the problem is you can't put 2 silicone tubes together because they have to come apart very easily. But if you put these 2 in harmony, they actually stay together really well. And the silicone is useful in that it's sticky. It's a sticky sort of plastic. So any microfine dust actually sticks to the inside of the tube rather than going deep into your lungs. So this is what I use now. Very useful in the mountains too. You can also link it together like so and put it around your neck so you don't lose it in the field. So you can see how well it attaches. Now that works really well in most situations, but not in sand dunes because you're obviously sucking up deep and taking possibly microfine sand particles into your lungs. You don't want to do that. So what I've started using is one of these artist travel paint brushes, and they sort of collapse the little tube, and then you can just do that. And that way you just dip that in your alcohol, and then you can pick up your money spiders, transfer them to the sample pot. It just saves you messing your lungs up for no reason, really. So that's what I found useful for collecting money spiders. Right. Okay, so this is going to be a bit of an ecological tour of money spiders and different species. And what I thought I'd do, I'd take you from the coast right the way up to the mountain summit and all habitats in between. So, so this is Snowdon, so highest mountain in England and Wales, over 1,000 meters. We're down on the coast here. Right. So you wouldn't naturally think that the shoreline is a good place to look for spiders. You've got seaweed washed up here, rocks. Obviously, the sea comes way up to the base of this cliff. Not where you'd naturally think you'd find spiders, but there is a species that lives here. And clues in the name, Halorates reprobus. Obviously, halo, salt. So start turning rocks and you'll find this sort of mid-size, very dark money spider clinging to the underside of the rocks. You can see on the maps, it's a very coastal species. Essentially, you're not going to get this inland at all. It's really down on the coast. And here's its egg sac. You see how big the egg sac is compared to the spider. It's put its eggs in there, covered them over with silk, and go grubbing around seaweed, strand lines, probably find that. So quite a rare spider globally, and UK has quite a lot of the global population because we've got such a nice varied coast. So yeah, nice one to find. Then we're going into Saltmarsh, so a bit more structure to this habitat, more vegetation. You've got we've got a sea purslane grading through Festuca rubra up onto a coastal path. So this is on Anglesey. And even down here where the tide comes over, you'll be finding spiders. They won't be out on the mud flats, but where there's vegetation and under those rocks, you'll get some spiders. So you'll get beauties like this Erigone longipalpis. And Erigones are really easy to recognize, actually, particularly the males. Their palps are usually elongate like this, and they've got this peculiar shark fin that sticks off the let's see, patella, I suppose it is. And then a very characteristic tibia shape there on the palp. And they've also got these robust spines on the legs and on the margin of the carapace as well. So just look out for those features in combination, and you'll have an Erigone, and then you're just focusing on that genus. And longipalpis tends to like estuaries, muddy estuaries down at the coast. You'll see there are some inland records, so edges of reservoirs, that sort of thing. So it likes it wet, tends to be coastal, that sort of thing. Quite a big money spider, really. It's a nice one to find. And Erigones are a very widespread genus. You've got essentially two species that are extremely common, Erigoniatra and Dentipalpis. And then you've got a raft of reasonably uncommon ones through to some mega rarities that you have to go to really specialized habitats to find. So good one to get to know because of those two common species, and a good genus to look out for because males are so easy. Females are quite easy to see because they're quite characteristic in the epigyne too. Another one you'll get down here is Oedothorax fuscus. Now, Oedothorax is another quite a characteristic genus in its look. The sort of female epigynes look roughly similar. But fuscus is easy because it generally has this pale dorsal stripe on the abdomen. And although the epigynes can look very similar across the species, fuscus is the only one that you're going to find with this pale band. Now, you do get fuscus females which don't have the band, but they tend to be rare. So that's a good tip. If you're struggling with Oedothorax, first look for that dorsal abdomen stripe. If it's that, you've got fuscus. This thing can turn up on the coast. Tends to like wetland habitats inland as well, but very common. Even sort of really thick grasslands, as long as it's quite moist, you'll get that. You can see by the UK distribution map there, it's ubiquitous really. Now we're getting into some of the rarities. So this thing I was contracted to look for. This is essentially a subterranean spider. And this thing occurs down on the coast, upper Saltmarsh. So you have to turn the rocks, and it lives in a small web in soil recesses under rocks. And it's probably also occurs in soil. There's certainly continental records of pitfall trapping it from subterranean pitfall traps. And you can see how small it is, very pallid thing. So it's also got those very small beady eyes. It's got all the hallmarks of something subterranean. And that thing I found, I did a contract for Natural Resources Wales, and I found one after many hours in the field looking for it. So just shows you can get these rarities hiding in habitats, but you really have to search for them. There'll be a lot of common spiders before you find something like this. Right, sand dunes. Fantastic habitat for entomologists and arachnologists. Lots of different unusual spiders here. And a lot of things that are tied to sand dunes that you won't find anywhere else. This is Newborough Warren. Fantastic frontal dune system. Okay, there's a pine forest here, maybe not so interesting for the arachnologist, but good patches of bare sand too. So you're getting this hot, dry, effectively a desert really, but you've also got dune slacks at the back. So there's a nice mosaic of habitats for different species here. And one of our specialities you'll get there is this thing with an unpronounceable name. So I think it's Styloctetor romanus. I suspect that record is probably erroneous, so disregard that inland record. But you'll see it's quite tied to the west coast. There's a few outlying populations in southeast Britain. Likes dune slacks, sort of dune grassland, that sort of thing, but it matures quite early in the season. So if you're looking in July, it's a lot harder to find midsummer than it would be in April time, that sort of time. So bear that in mind. Some of these rarities are rare because they don't correspond with the traditional field season. So there are a lot of winter maturing money spiders that you will just not find in summer. They're really common. So that's a nice tip. If you want to find something rare, go out in winter. You've got a higher chance of turning up new square records, new vice county records then. So yeah, nice, good dune indicating species really. I've come across these quite frequently. There's 2 reports I've done recently for Natural Resources Wales on 2 of their NNR dune systems in Merionethshire. So quite nice if you want to. I think they're online, so you could probably find them, and it sort of explains all the different spiders and where you find them. Right. So Anglesey is a good place because you've got the coast, but you've also got these fabulous fen habitats. So this calcareous fen, and although this just looks from the photo like a load of Juncus effusus, it's actually Schenus. It's a really, really nice basic wetland. There's some Erica there, and get the vacuum sampler in there and you'll turn up some really nice things. Okay, this is another common wetland spider, but quite distinctive because it's got these carapace punctuations, these little dots along the stria, these sorts of stripes that you get on the carapace, and they're like little bobbles, I suppose, like that metal plate that you walk on, the anti-slip on it. Always this very dark, sort of reddish colour, very characteristic. Go into wetlands, you're going to get wet feet looking for this thing. Get the sieve, grab a load of, I don't know, Juncus litter, anything like that. Pass it through a sieve, Phragmites beds, that sort of thing, and you'll turn this thing up. It's a really nice thing, but you can see how patchily distributed it is, and you sort of naturally think, oh, is this because it's a natural distribution? Well, no, it's not. It just corresponds where there's people that have prepared to go and get their feet wet or go out with wellies on. So if you haven't got wellies, you're probably not going to find this. So just look at that map. You can see there's huge areas of UK which are under-recorded. It's probably that people just don't like working wetland habitats. So focusing on, I've got this saying, rare spiders occur where people don't like to sample. So look for difficult to work places and you'll turn up goodies. Right, another nice reddish wetland spider, Hypoma bituberculatum. It's got these 2 bumps on the head in the male. Another one of these species with a modified head structure. And it's got that really characteristic orangey colour to it with a black abdomen. And these are very common in wetlands. You'll find these in Phragmites beds, a ditch with a bit of Juncus effusus in, you'll find it. So probably one of our commonest wetland spiders, but once again, you can see there's vast areas in mid Wales, parts of Scotland. Probably doesn't tend to like the sort of peaty, acidic bogs as much as more sort of nutrient-rich wetlands. So that probably accounts for a lot of the gaps in Scotland and probably mid Wales too. Some of the rarer wetland spiders. So we've got Paracymbium gowerense here, and that's type locations actually on the Gower Peninsula. And you can see just how restricted it is. It's a couple of fenland sites in East Anglia, fens on Anglesey, fen on the Clean, bog in mid Wales, and Also occurs on Saltmarsh, strangely enough. So Juncus maritimus down on the Gower, but strangely enough, I can't find it on Juncus maritimus anywhere else. But it's an early maturing species, so you've got to be out early in the season to find this. So that's probably why it hasn't been found too often. But yeah, very characteristic abdomen as well. It's got this sort of pincushion effect on the abdomen that a lot of the other money spiders don't have. And I've done a report on that, so you can find that online and see what sort of habitat it likes. Very bristly species. It's got this sort of catching basket on its front legs. The spines are arranged in a sort of parallel series of spines, like a catching cage. And presumably they use that to grab their prey, whatever they eat. I don't think people even know what these things eat. I guess they're things like springtails and probably any invertebrate that they can overpower. Okay, river shingle. So this is almost a bit like the coast, really, but inland. And it doesn't look like a very inviting habitat for an entomologist or an arachnologist. It's just essentially a pile of rock next to a river. And it can be really hot, baking hot, in fact, dry, not necessarily a place where you think you're going to find a lot of species. And that's true, you're not going to find a lot of species, but what you're going to find are interesting species. So probably one of the common spiders you'll find there is this thing, Oedothorax applicatus. And here's the male, very interesting head structure. It's got these little sulky pits on the side. Another one of these that produces that food during courtship for the female. Strange enough, it's quite widespread. The records in Britain show it to be widespread, but actually when you actually find it, it tends to be only in dry shingle and really dry rocky areas. So because it's quite a frequent aeronaut, so it's one of these ballooning spiders that will travel on silk quite a distance. It does turn up in areas it might not necessarily live in. So that could well account for why it looks more distributed than it actually is. So what you're doing is just moving the shingle around, and these little spiders are living in the gaps between the shingle. And yeah, you should be able to find this one quite easy. Okay. Right. I did explain how shingle, it's not a very promising habitat. A lot of these little tiny stones at midday will heat up to such a point that you won't even be able to pick them up, particularly if they're quite dark. So naturally, nothing's going to be wanting to live anywhere near these things. It's just too hostile an environment. So in these shingle habitats, what you're looking for are big rocks, because big rocks take longer to heat up. They're more likely to have moisture underneath them. So these things can just be baked, parched, dry underneath, and you're not going to have a tiny little spider living under them. So you're going for the bigger rocks that are sitting on top of this shingle matrix. And there'll be some, you'll notice that the footprint of the rock will be moist. And in amongst the little gaps there, you'll be finding spiders. So yeah, not all rocks are equal. And this equally applies when you're working out in the grassland habitats. So if it's a really hot day, don't bother looking under the small stones, because they'll just be uninhabitable underneath. It's too hot. Pale stones, probably better than dark stones to look under. But you'll generally get a feel for what is a nice looking stone to turn at. I know it sounds a bit daft, but you can hone in on, oh yes, that's a good stone. It looks like it hasn't been moved too often. It's a good size. It's going to have something under it, and chances are it does. So you can waste a lot of time turning these small rocks and not finding anything. And what you're looking for in those river shingle habitats are specialist things like this Caviphantes saxatorum, only found in river shingle, microscopic job, pallid, that's a millimetre scale. And you can just see how infrequently this thing is recorded. Obviously, that's restricted by habitat availability, but it's also restricted by knowing how to look for it. So Most of the mid-Wales records were done by Adrian Fowles, who was working on river shingle invertebrates. So he honed in on how to look for this thing. Even some of these Scottish records are because he knows what to look for. So just get into that mindset, looking for those stones that these things look like, and you'll find it. And there's no reason why it shouldn't be more widespread in Scotland. Certainly mid Wales has got to be more populations. Almost certainly in Hexham area, that Lancashire area, loon shingles, I believe that spot is. It's there, but it's got to be more widespread than that. But nobody's looking for it because it's difficult to find until you know how to look for it. So we're moving into grasslands. Well, yeah, radically different habitat from that river shingle, much more vegetation involved, quite difficult to sample by hand. Often in summer, these places can be parched, dry, it's hard to find. So early spring, this time, September time. So often the golden months for spider recording are May, June, and then again in September. So July, probably less so because it's so dry and hot to work. And obviously winter's good, but you've got to be wrapped up warm. So that vacuum sampler comes in very useful in a habitat like this. There's not so much loose vegetation, so you're just passing it through this grass, you're rapidly sampling it, turning up lots of nice things in there. So this is calcareous grassland, obviously we've got limestone jutting through. Not modified too much, it's got the occasional grazing sheep, but it hasn't been grazed to death, it's got some structure. That's a good habitat to look for. But you'll get spiders that live in really short, close cropped, rabbit grazed grassland too. So investigate that as well, because you'll be turning up things like Typhocrestus in the really short grass, and you'll get different species in the longer grass. So don't assume it doesn't look worthwhile, just do it, see what comes out. Right, I mentioned the Erigones, very common things. Ballooning specialists, this Erigoniatra, I would be surprised if it doesn't actually occur in every 10k square in UK. Pretty much any garden lawn will have this thing in, even if it's mowed to Bowling Green standards. It turns up everywhere. Very common thing. Get to know that one, go to the Roberts book, look at the pictures, get it in your mind because it'll turn up everywhere. So it's worth doing that. Grasslands can turn up some nice things as well. One of these head-modified males again, Peponocranium ludicrum. Got incredible structure on the carapace there. Very small thing, but unusually pale as well for a money spider. So you can see these, they're just starting to mature now, in fact, within the last week or two, where I live anyway. So nice one to look for. Grasslands. You can also beat this one out of gorse bushes too. So that's what's strange about some spiders. They're not tied to a certain habitat as such. They're tied to conditions, I think is probably more appropriate. So I don't know, I suppose the inside of a gorse bush must be quite similar to a grassland in sort of humidity and temperature and what have you. So peculiar. But that's quite a widespread and quite a nice thing to find actually. Very small. Another really common grassland spider is Tenuophantes tenuis. Now, I know the Spider Recording Scheme did an analysis of all the records of British spiders, and this thing turned out to be our commonest British spider in terms of record. It's pretty much everywhere. And it's quite variable in colour. So these are what I would term the classic colour. The guanine deposits give it this white background, and these black spots are very noticeable. And when you see them in the field, you're pretty sure that's Tenuophantes tenuis. But you can get darker individuals like this that can fool you, because although you can see the underlying pattern is still there, it doesn't look like the same species. But there's a case where you have to go to the genitalia to be certain. yeah, it's another one of those spiders that turns up everywhere. Tends to like it a bit thicker grassland, but vacuum sampler in your garden, in coastal grassland, road verges, this thing will turn up. It's ubiquitous, it's everywhere, really easy to find. So another one to get familiar with in the books, and you'll definitely find this one. And you see just how common it is. It sort of peters out in the uplands, tends not to like acidic wetland habitat. You'll generally find it in drier grasslands, really, and sand dunes, yeah, marram grass as well. I thought I'd pop this image in because it shows that spiders do get parasitized. So we've got a Hymenopteran larva actually attached to the outside of this money spider's abdomen. So that's quite interesting. You do occasionally come across these, and you can rear them through and find out what the Hymenopteran is too. Okay, yet another ubiquitous common grassland spider. This thing turns up just about everywhere. A little bit smaller than Tenuophantes tenuis, but quite variable in the abdominal markings. So this herringbone, like one of those cartoon fish skeletons that Tom and Jerry would have on, is probably the classic form that you'll find. You'll also find a form that doesn't have these black chevron markings. It's pale with the black margins. That seems to be slightly less frequently found, often with a tinge of pink to it as well. But if you go into the uplands in sort of blanket bogs, that sort of habitat, pretty much all the specimens you'll find will have a unicolorous grey abdomen. Now, that's quite important because there's a closely related species called Bathyphantes parvulus, which in the books it actually says this can be separated because it has a uniformly coloured abdomen. Well, that may be true in most cases, but if you come across these upland examples of gracilis with that unicolorous abdomen, you could make a mistake. So just keep that in mind. It's useful to know. I struggled with those upland ones for a long time, thinking, what on earth have I got here? It doesn't really fit in with the books. I even got to this point of dissecting them to find out the internal structure of the female genitalia to make sure it really was gracilis, and sure enough it is, but just something to bear in mind. So the habitat does seem to have a sort of leaning towards what colour forms you get. Another nice grassland one, quite a big species for a money spider, very characteristic with this black stripe down the middle. Tends to be easier to find in winter. It seems to mature in winter, early spring. Harder to find in summer, really. But the actual classic of this species is that it has a palp that looks like a horse's head. Absolutely wonderful thing. It's even got the tongue and the ears and an eye, and I suppose a couple of teeth as well. So once you've seen that palp, you're not going to forget it. It's brilliant, really. Right, now we're getting into territory of really unusual things. So you've got cave-dwelling money spiders too in Britain. So this is one of these limestone caves down in South Wales. And here we are. This is Britain's only proper cave spider, really, cave-adapted species. It's pallid, translucent, very reduced eyes. They're probably non-functional, really, elongated legs. And it only occurs in 2 caves in Britain, so caves in Ireland and other sites on the continent. So in terms of UK populations, there's only 2, which is amazing, really. And it lives in this little sheet web, and the web is so flimsy that you can just blow on it and the web just disintegrates. So because it's living in a cave atmosphere, cave environment, the web doesn't have to have any strength. There's no wind to smash it up. So it's very economical with the strength of its web. An amazing thing to see. Tricky to photograph because it's in all the nooks and crannies of these caves, but wonderful, interesting thing to find. And a lot of these paramours are subterranean, so you'll get some species with slightly reduced eyes that live under big boulders in mammal burrows, that sort of thing. So they're quite tricky to find, some of the rarer paramours, because of that. I'll tell you a tip how to find some of these more unusual ones later. Lowland raised bogs, always a fantastic site for spiders, and essentially any other entomology or arachnology now. This is Bettesfield moss, Wales, England border. And this is this wonderful hummock and hollow topography that the surface of raised bogs have. And this is the absolute pristine, perfect environment for looking at. You're on a bit of a bouncing bog here, one of those shring moors, bounces up and down and undulates when you're on it. People are always warning, oh, very dangerous places to go, you'll get sucked in or what have you. Yeah, if you're lightweight and you're careful where you walk, they're actually not too bad at all. Just don't go where it's bare sphagnum, stay on the hummocks. But it's these hummocks actually surrounded by waters where all the rarities live. And you'd look at this and you think, oh, that's pristine habitat, but actually this is an artificial habitat in this case. This was created by dynamite or some other explosive. So the owner of Bettesfield Mosses back in the day wanted a duck pond and apparently set off some explosives to create a pool, and all the peat went up in the air and slopped back down again and blocked all these drainage ditches and accidentally created this wonderful habitat that we've got now. And I'd say most of the Fens and Wixel rare money spiders and pseudoscorpions are in this habitat. So that's what you're looking for. And it's sort of become one of these nice hummock and hollow topographies here. Okay, nice acid wetland species. It's fairly common, but I always associate it's one of those things, if you find it, you know you're in a good bit of habitat. It likes acid wetland. It's really tied to that. And quite a characteristic thing. It's sort of reminiscent of a jelly bean, really. It's quite shiny, very red carapace. You go to an acid bog with a vacuum sampler, you're going to turn this up. And once you start turning this up, you know you're in some nice habitat. You might start finding some of the other rarities too. So good one to look out for. And you can almost identify this one in the field if you're in the right habitat. It has a very characteristic look about it. But that's with experience and looking at them down a microscope first and getting familiar with what their features are and what have you. Now we're getting into the realms of some of the raised bog specialities, these what I call bog standard spiders. So Cararita limnea, that's a really rare thing. That really likes these bouncing bogs, and it's only in 2 locations, 2 or possibly 3 if you treat Bettesfield moss as a different moss to Fens and Wixel. Very rare, but if you go down to Wimbury moss with a vacuum sampler, pretty much every sample will have this in. So although it's rare nationally, on Wixel moss, it's almost the commonest spider you can find. So it's peculiar like that. It makes you question what's rare and what's common and what have you. Glyphesis cottony, very tiny spider, sort of almost about a millimetre body length or less. And this lives in the saturated sphagnum in pools. So it needs a really high water table and it will be living in there. And it's like a full stop of it, essentially. It's so small, very hard to find, but quite a speciality of the sort of Cheshire, Shropshire Plain area in the raised bogs. And then Minicia marginella, this in places like Denmark, very characteristic of raised bogs. This turned up in a survey for the Tanyptera Trust on Fens and Wixel, strangely enough, in a habitat quite similar to where it is found in Denmark, and alongside this guy here, the Cararita. So you see that little habitat was turning up lots of really interesting things, and this is only known from, I think it's 3 sites in Britain. One is near the Channel Tunnel excavation. It's a bit of an odd one. It's not a bog at all. And then a bog up in Northumbria, and then Fens and Wixel. So interesting in that it looks a bit like a humbug. It's got the lateral dark bands and a very strangely modified head, like a balloon coming off the top. Okay, and they're all in a Tanyptera Trust report. If you want to look into that, I think you can get that on the website there. So now we're getting into deciduous woodland, another habitat. So what you'll see is that as you're going through the different habitats, you're getting different species. It's like anything, you've got to be in the right place to find it and home in to look. So if you keep going back to the same site, you're not going to get a nice range. But if you visit different habitats, try different search techniques, you're going to find different things. So this is probably one of the most interesting sort of woodland things you'll find easily. And this is a money spider that doesn't really make a sheet web. It acts more like one of those tropical sparassids that actually sits on the trunk of a tree and spreads out. It sort of runs up and down, and very interesting to see and quite difficult to find. You can do bark brushing for it, or you can just keep your eyes peeled on trunks of trees. And if you notice the modifications, it's got that catch basket again on the palps, those double row of spines on the palps. And I'm assuming that that's because it's not using its web to ensnare prey. It's actually grabbing stuff with those palps and transferring them to the chelicerae there for the bite. Really attractive thing, really, when you see it in life. Very distinctive epigyne too. So that's one to look out for in woodlands, certainly. You wouldn't find that away from a woodland. It really is tied to woodland. Another sort of woodland species is Labula thoracica, another one of these larger money spiders. Very annulated legs, hangs upside down in a web. So if you've got an old rotten tree stump that's just sat there, you'll see sheet webs at the bottom. Often it's this species, and it will be tucked away in a recess in some of the rotten bark. If you've got a cellar or some other dark place like that that's moist, they'll also occur there. And they've got 3 characteristic little white spots next to the spinnerets, which is quite nice to see. And really distinctive epigyne on this species. If you go to the books and look at the epigyne on this, you can't mistake it for anything else in Britain. Really big, obvious, definitely nice to find. Then you've got this species that actually looks quite similar to Labula thoracica, but it's a fraction of the size. And this is Leptophantes minutus. It often comes into the house as well. So I tend to get it coming into the house and walking on the walls if you leave a window open. So obviously lives outside, and it just comes in. Once again, if you're grubbing around an old rotten stump, you might find this. Really characteristic annulated legs again. Leptophantes is actually a big or it was a big genus that's been subdivided into lots of different genera. So in the Roberts, you'll see a lot of species listed under Leptophantes, but they've actually all been subdivided into several different genera, all helpfully with the name Phantes in it. So you'll have things like Tenuiphantes, Oreophantes, Pallidophantes, and so on. But in the book, they're all under Leptophantes, so just bear that in mind. So going on to some more Phantes. I've left that Tenuiphantes tenuis in, that grassland species we saw earlier, but it has a woodland equivalent, effectively, which is Zimmermanni. And this has these chevrons on the abdomen as opposed to the dots. And they are pretty similar. They look very similar, but you'll find this thing living in leaf litter. But you'll also find it on the summits of mountains, under rocks too, and in moorland. So it appears that it likes a more humid environment than tenuis. So that's probably the reason. It's not the habitat per se, it's the conditions that are formed within those habitats that it's going for. And everybody's favourite, Valcanaria acuminata, it can turn up in quite a lot of different habitats. So you'll find this in acid bogs, blanket bogs, woodlands, thick grasslands, whatever. I believe it actually eats other spiders as well. Somebody mentioned that to me, but I don't know. Quite a nice thing. The female also has a raised head, which is quite unusual. I think it's the only one actually where the female has a raised head. And you can even identify these as subadults. So before the epigynes form, before the palps are formed, because they'll have a rudimentary structure that is sort of suggestive of this eye turret. And there's nothing else in Britain like it. So it's not going to be anything else. It's going to be this. So you can record that as a juvenile. So there you go, a dead easy money spider that anyone can identify, even as an immature. Now, there's not many spiders you can say that about. So now we're entering heathland. Well, this is Bickerton Hill. I think we had a Tanyptera day, recorder's day out on this site, and really nice place, really. Quite under-recorded site. Heather on a sandy background there, bit of acidic peat, I guess, heather peat or what have you. And we were walking along, and this is one of those rocks that just jumps out at you. You see that. Clearly it hasn't been moved for a while. It's turnable, it's not bedrock, but it's on sand. And you think, well, that's one to turn, definitely. So you flip it over, and you see all these ant galleries, loads of ants running about. You think, well, ants are quite interesting because there are many spiders that actually live with ants, these myrmecophile spiders. And what caught my eye are these egg sacs, because all these egg sacs, they're actually within the ant galleries. So immediately you go, right, we're onto something here. There's only one spider this can be on: dryish, acidic, peaty habitat, ants under rocks. Right, you can see how closely associated with the ants this is. There's the ant pupa, there's the egg sacs. It's within the galleries. And it's this thing, Avensia mirens. Dry peat, ants, it's this. Quite under-recorded, you can see, and it's got quite a nice distribution. It's very much that old Rock of Britain distribution with a few outliers. So it likes that. Strangely enough, it's not on the Dorset Heaths, which is a bit unusual. Maybe there's just not enough rocks around to turn. But I've got a site near me where I can find it quite easily, but you don't find it too often. You've got to go turning rocks. You're very unlikely to find this by vacuuming because it's within those ant galleries. And actually looking at the spider, you can see it does have some structural modifications. Those abdominal hairs look quite unusual for a money spider. So it obviously lives in quite close association with the ants. Quite what it's eating, I don't know. Maybe the springtails down there, other myrmecophile invertebrates, or possibly even the ant pupa themselves, but I don't know. Now we're going into blanket bog. A little bit eroded there, these peat hags, not always a good sign, but the thing is with blanket bog, it's an all or nothing sort of a site. So actually this drier area of the blanket bog, it's not that good really for rarities, but what you're looking for are these runnels with the juncus, the Erigone, both species, and these sphagnum lawns. Whenever you see a sphagnum lawn over water, that is manna from heaven to find rare money spiders. And it's actually quite a difficult habitat to survey because this is over a skin of water. So if you're just in normal wellies, the water level's too high. You're almost having to go swimming pretty much to find these things. And that's why these things are under-recorded. And who wants to go up there in midwinter, 300 meters in cold weather? Well, you probably only go swimming in this in June. But remember those rare Erigones I was telling you about? There's a rare one here that lives in sphagnum lawn called Erigone welchi. Now, very rare thing. I don't know off the top of my head how many records, but probably very few sites in Britain. You can find it on the Spider Recording Scheme website. But you have to go teasing this sphagnum, sort of parting it with your hands, looking for the little webs that are on there. And that's the way to find that. Now, those sphagnum lawns are difficult. You don't really want to be grabbing all the sphagnum and passing it through a sieve, because that's not the most ecologically nice thing to do. And sphagnum doesn't mind, it'll regrow anyway, but not a good thing to do. But you can home in on the webs of these things by looking for these dew encrusted webs. So it's not really a sheet web as such, it's more of a tangle web, but you'll see these little webs on the sphagnum lawn, and you can just part them with your fingers, and often the spider will be hiding under one of these sphagnum heads, and it'll show itself as soon as you start parting the web, and then you can just pooter it up. You'll get the common Erigones in this habitat too, so you'll get Atra, dentipalpis, often promiscua too, but you'll also get those rarities like, I've forgotten its new name, it's Erigone capra, seems to like this sort of habitat, it's changed its name recently, and Erigone welchi, of course. So sphagnum lawns, look out for them. And you get some common spiders in that sort of blanket bog habitat, like Gonatium rubens. It's a nice reddish spider that is quite obvious in the field. Any heathery area, dry heather, wet heather, raised bogs too, this thing will turn up. Then you get in some of the rare upland blanket bog species. So in that same wetland habitat, those runnels, you get things like Hilaria pervicax. Further north in Britain, you'll get things like Hilaria nubigina. Really good things to find, very under-recorded. And you can see it's sort of the uplands of Wales, Teesdale, that sort of area, and then Scotland. But of course, these things are up at altitude, and under-recorded sites, people tend to stick to the lowlands if they can, because it's obviously hard work getting into the uplands to look for these things. Now, here's a tricky one. This is not actually a money spider and is quite easy to mistake for a money spider. It looks like one. It's got a shiny, leggy look, dark look to it, but this is Robertus lividus. It's actually a thoridid. So there's quite a few thoridids that are worth actually getting to know because they look like money spiders. And Robertus lividus is definitely one. Another one is Theone minutissima. So check them out in the book, get familiar with what they look like, because you can spend hours trying to identify these when you're starting out. Thinking, I don't recognise this money spider at all. Another one's Enoplagnatha thoracica as well. That's another one that tricks you. So get to know those three thoridids, and then you can save a lot of time trying to find them if you think they're a money spider. Yeah. Right, another really rare blanket bog species is this thing, Maurolepidus. Really small thing, it's less than 1 millimetre long and very restricted. Seems to like those sphagnum runnels with juncus. So the sphagnum has got cold water running down the runnel and then juncus sticking up through the sphagnum. And you can sieve a bit of the sphagnum or vacuum sample it, and you can find this, but very infrequently and very hard to find. Some of the sites where it's been recorded, I can't find it again now. So maybe the habitat's changed or something. There are 1 or 2 reliable habitat sites for it. Okay, upland acid grassland. That's pretty much the commonest habitat you're going to get up in Snowdonia or what have you. It's actually not a natural habitat. Looking at this view, this is Plynlimon looking down into Cardigan Bay. And it looks fantastic scenery, doesn't it? But it's all man-made, of course. This acid grassland is essentially a sheep-modified habitat. You've got your artificial reservoir, you've got your plantation of pine. So although it looks like a nice, pristine habitat, it is a man-made environment. But there are interesting spiders here. Not that interesting, but they're not bad. So we're starting to get into the domain of these Arctic alpine spiders, these sort of northern spiders that live at high altitude. And this is probably one of the more easy to find upland montane spiders, this Messianagus morulus. And you'll find this in acid grassland. So it's difficult to find unless you've got a vacuum sampler. So vacuum sampling upland grassland, particularly around rocks, you'll probably turn this up quite easily. It gets down to about the Brecon Beacons, that sort of area. There's a few wild cows. I suspect that's an erroneous record. It might be Lichfield, I think. I think there were some old historical records recorded by somebody called Carr of Lichfield, and I think the records went in as Lichfield, but it was just an arachnologist based at Lichfield. But you can see it's got that Pennines distribution, that Snowdonia, Mountains, Scotland distribution. So that one's the easiest upland one to find. Quite small, but a grassland thing nonetheless. You do turn it up under stones, but you can find it in numbers in the grass up there. Obviously, you won't find that down in the lowlands because unless you're really far north, you'll only find it about 300 metres upwards. So I mentioned ballooning spiders earlier. So ballooning is an interesting dispersal method that Linyphiidae use and a few other spiders. So what will happen is that the money spider will crawl out of its environment, go to a high perch, in this case a fence post, and then it'll let out some silk as a little strand or a multi-strand, like a multi-strand of silk like that. And then once the wind grabs it strong enough, or actually an electrostatic difference between the ground and the clouds will also draw it up off into the air. And then it will be transported on the wind in these electrical currents, and it can drift hundreds of miles on and occupy new habitats. I thought that was quite a nice photo. It had some paragliders in, so the spiders are actually ballooning, and so are the people. But these are actually very useful structures to look for, these fence lines, because essentially they're just a large net. So anything that's ballooning on a day like this will hit this, the silk will entangle on the fence line, and then the spider will have to crawl up again to the fence post. So all you have to do is walk along the fence posts, and you find these little spiders just sat on the posts, and you can just collect them off the posts. And I've turned up some really interesting things on this sort of species that live in mole burrows, like Paroma campbelli, things that you'd find it very difficult to actually sample by actually digging in the soil or what have you. But you'll find them in their dispersal phase. So they're obviously moving around to exploit new mammal burrows. So that's a nice tip. If you want to look out for rarities without having to grovel around, they're all at a nice convenient height to find. Walk along a fence line like this in ballooning weather. You'll see the spiders, you'll see the silk, the gossamer, and you can just pick them off at leisure. And you'll get a nice little sample of various things. But the thing to bear in mind is that the spiders that you'll find ballooning aren't necessarily the spiders that you'll find living in this habitat. So you might find lowland species on these fence posts that you'll never find living in the habitat because they've simply bloomed in. So it does sort of make it a bit strange. Are you actually doing a proper biological record? Because they are effectively accidentals in that habitat. So to call into question what you're recording there. Okay, so we're getting towards the end of the talk now, but I thought this would be a nice little slide to show you, because these are 3 Agonita, and they are, in the book, they're actually quite close together. They all look very similar, but the nice thing is that they're altitudinally distributed. So as you go up with increasing altitude, you get the rarer species. So Agonita rurestris is effectively a lowland spider. Any sort of grassland you'll find it in. It's not particularly fussy. As you sort of get into the mountain habitats, Gullosa starts to appear. So you won't find Gullosa down at sea level in the south of Britain, really. Up in Scotland you might, but it's very much a mountain thing in Snowdonia and sort of north, sort of Lake District. And then you'll get nigripes, but actually they look very similar, but nigripes has got these googly eyes, and this is an extreme montane species. In North Wales, it only occurs at one site at 1,000 metres, and it doesn't occur in England. There's no records. And it's more widespread up in Scotland. So what you're getting is this nice altitudinal distribution with these spiders. But going back to that thing I was saying about the ballooning, you will occasionally get ruerestris on those fence posts at altitude. So you can't assume that anything you find in the mountains is gullosa, because occasionally you'll get a ballooning in ruerestris. But nigripes is a sort of once in a blue moon find. It's a really difficult one to find. So that just sort of gives you an impression of the distributions there. So the altitudinal ranges are a bit skewed because of the far north records. Some of the ones are down at sea level, but you can see this high altitude nigripes. It's on the northern slope of one of the 1 kilometre high mountains in Snowdonia. That's the only place I can find it. I've hoovered other places. I can't find it there. You can see up in Scotland, it's more widespread. Misses out the Lake District. And gullosa, the next upland one, does occur in the lowlands, but these could be ballooning ones. I've been up on Snowdon and found gullosa ballooning in numbers. So many of these could be accidentals. And then obviously ruerestris, you see in lowland Britain, common. So yeah, quite a nice little group of three there. And they look suspiciously difficult to identify in the book, but there are a few pointers. Certainly those eyes are very critical in identifying nigripes. You can easily mistake a dark gullosa for a nigripes unless you look for those googly eyes. I've just popped this one in, Centromerus bicolor, simply because it's a winter maturer. It's like Centromerus consina. They're much easier to find in the winter months. So November, December, January gets difficult by summer. There might be the occasional female just hanging on, but no, much easier. You can find them by the hundreds in winter, and then they become almost unlocatable in summer. So you can see large areas of Britain under-recorded for this. South Wales, Mid Wales, lots of northern Britain. It's definitely there. It's just a case that people haven't been out in winter looking for it. So pick the season and you can get some good records there. Just want to illustrate a nice web, really, of a money spider, typical sheet web. Tapinopolongidens. This is another of those winter things that are easy to find in winter than summer. And the egg sacs are nice because they're actually shaped like a fried egg, upside down fried egg. And they're either attached to the stone or they're attached to the actual sheet web. And really characteristic dense web under stones that you can find it. I've just popped that one in simply because it was found in an upland pitfall trap, just to demonstrate parasitism in money spiders. So that's a nematode worm that's exploded out of a money spider in a pitfall trap. And it's just amazing to think that that spider was walking around alive with something that big coiled up inside its abdomen. Incredible. And okay, we're virtually at the end of the talk now. So we've got to the summits of the high mountains now. This is where you get these Arctic alpine relics, these things that during the last ice age in the tundra, these were at sea level. As our climates gradually warmed, these things have retreated up to the mountain summits. They're essentially stranded in what are effectively islands of habitat in a sea of unsuitable lowland habitat now. And I found this fascinating. Americans have got a nice term for it. They call them sky islands, which is quite nice when you think about that. And if you can see it, it's huge areas of this acid upland grassland that has been created by the sheep. Really, all these mountains should be heather, thick heather, grading into bilberry and then montane heath and then rocks on the top, with probably some forest in lowland petering out. But we've grown up in an environment where this is what we think mountains should look like. Well, yeah, this is a man-made habitat, but actually these felsen meres, these rocky shattered block fields on the summits, these probably have always looked like this. Maybe would have had a bit more bilberry on them. But this is the habitat where you're getting the real Arctic alpine montane spiders that are living at this cold habitat up here. And you've got this Raccomitrium moss, this real nice stuff from snow laying for a long time in the season too. And the reason why they're still there is it's a climatic thing. So I went up Snowdon, I walked up Snowdon, probably recognise the view, looking out over to Anglesey in May 2012. Well, down on Anglesey on that day, it was 10 degrees C at sea level. And you then have to take into account this thing called the lapse rate, which is the decreasing temperature with altitude. So it varies across the globe. So in the tropics, it's a totally different lapse rate than what we have at our latitude. But I found a figure, it's roughly 0.5 degree C for every 100 meters of altitude you climb. So it might be 10 degrees C down at the coast, but if you're up at the top of Snowdon on that day, it suddenly drops to 3 degrees C because of the elevation. And you can see that's climatically, that's a different environment. You are in essentially Arctic tundra pretty much. And that's why those Arctic alpine spiders are still there. I've even taken some Arctic alpine spiders down to photograph at sea level in my home, and they haven't lasted long, so I've had to keep them in the fridge to actually keep them alive. So there obviously are quite thermally intolerant, some of these species. So I think with climate change, we could lose some of these southern populations of these Arctic alpines. And interesting thing to study, really, and see if they're still there. And I'm just going to finish this talk, really, with one of the real nice Arctic alpines that we've got. So Piniphantes pinicola. It's one of those phantes again. So it used to be in Leptophantes, but you won't find this in the lowlands. This is real high mountain species. I found it down to about 500 meters in sort of rocky areas, but generally the nice altitude in Snowdonia at least is 750 meters plus. And at that sort of point, then you're starting to get your Arctic alpine species. And you can see really interesting epigynes sticks out. Amazing looking thing, really, and very under-recorded. And you can see, strange thing though about this one is I've always sort of wondered about this because it's an Arctic alpine spider, very common in Snowdonia, the high mountains, Lake District. Look in Scotland, there's got to be loads of good habitat. And then it sort of dawned on me that this is something that's easy to find in autumn and spring, but these are times when in Scotland, most of the mountains are blanketed in snow, so there's no chance of actually finding it. But it's a lot harder to find in summer. You'll get the odd female still persisting, but much easier to find in winter, autumn, spring. So that's why it's a lot easier, obviously been easier to find in the Lake District and these milder mountains, I suppose. Okay, so I'm just going to end with a few resources that you can take away and go off and look at yourself. So I think primarily, if you're into spiders in Britain, you must join the British Arachnological Society. Well, you don't even have to join, to be honest with you. You can just go on the website. Spider Recording Scheme website is there for anyone to look at. You can see the distribution maps, lots of nice species ecological descriptions of where you find the species. British Ecological Society, been going many years. It's got some fantastic web resources, newsletters, bulletins, all online that you can log on to and get extra information. In normal times, we have an annual field trip where you can learn from other arachnologists. That's always a nice thing, and they have a course for beginners too. So check them out. Tanyptera Trust courses. I've been asked to hold an actual face-to-face course teaching money spiders later in the year. So keep your fingers crossed that COVID is on the way out, and hopefully we can run that later in the year. So watch out for that. And that's what I'll do. I'll take you through actual specimens of money spiders. It's a lot easier to learn money spiders by seeing specimens as with anything. And then there's online resources. So there's a wonderful website, what is it called now? Spiders of France and Belgium, or something like that, by Pierre Auger. And he's got some wonderful microscopic photographs of the palps. So if you find it difficult using the books and interpreting the line drawings in the books to what the specimen actually looks like, you might find it easier to actually see the photographs on Pierre's site to interpret some of the transparent structures. So horses for courses. Some people like the books, some people like using Lockett and Millage, some people are Roberts people, others like the online resources. And yeah, try them all out if you're just beginning, see which one you prefer and get on with it. See, and like any identification thing, it's time in the field, it's looking at specimens, hours down the microscope, going through the books. And when I first started, the most useful thing I found was just to sit down at night, turn the TV off, just go through the book, looking, reading, looking at all the illustrations, and it sort of embeds in your mind what these images are like. And then when you actually see the specimen yourself, 2 months later, you go, oh yeah, I've seen that before somewhere. And you can almost go straight to the page and go, oh yes, it's definitely that one. So it's a way of bypassing a lot of that, working through the tabular keys with your Trichobothrium and what have you. So that's what I would recommend, is getting that search image, I suppose, in your mind of what these things are. And it'll actually home in on different genera. So you'll rapidly know what an Oedothorax is, you'll rapidly know what an Erigone is, and you don't even have to go through any of the keys to get to that genus. You're there because you know what they look like. And there's some old friends that are just so characteristic, like that horsehead one, Steamonophantes lineatus. Once you see that, you'll never have to look in the book for that one again. It's just, yeah, it's that. So, yeah, although it's an overwhelming group to start off with, it's like anything, it gets easier. And it's a nice group to do because it's quite underworked. And there's mature money spiders every day of the year. So you can be out on 1st of January all the way through to the 31st of July, everything in between. So it's not like a butterfly season. There's no defined collecting season. Every day is a spider collecting survey day. So that's what I'd recommend. And don't forget to go out in winter, because that's when you get the goodies too. Okay, so I'll hand you back to Gary. I think I'll stop sharing my screen and we'll take a few questions.
Yeah, that was absolutely brilliant, Richard. Thank you so much. I mean, you covered a real breadth of different parts to money spider recording there, and going through really good tips on morphology, looking for hairs that move as finding the Trichobothria, and I always like asking you about equipment. I really like to go through the detail on the different pieces of equipment that can really just be helpful to you. Yeah, and then that just an amazing journey through the habitats, a broad range of habitats and various distinctive species that can be found, and just the specialists of the things you can expect to find in all the way up to the mountaintops. And that cave spider, I'm sure, maybe it's in the Lancashire cave system is one of the biggest in the country, and I just wonder whether
there's some tantalising clues on the continent that same species has been found in chelicerae as well. So it may not just be restricted to caves. So if you've got those big limestone screes deep, could be hiding in there, and we just don't know it yet.
So yeah, lots of fascinating stuff, really. Thank you so much, Richard. I think we'll go into questions now. I think there was very early on there was a comment from Alan Can just mentioning that the Trichobothria can be knocked off, but the pit remains. So
I sometimes find that pit difficult to find. I don't know if it's the optics on my microscope or not, but yeah, you can sometimes see it. It's often a darker spot, but occasionally the spines will break off, and that dark spot you could mistake a spine hole for a Trichobothria hole. It is sometimes raised, the Trichobothria socket as well. So you can look out for that, but I just find it's a lot easier just looking at the other side. If it doesn't appear to be there, have a look at the other side, other opposite leg, and then it sort of helps. If it happens to be there on the other leg, then you know it is actually present or what have you. But yeah, it can be difficult, and certainly with some of the vacuum sampled specimens, you can lose the odd Trichobothria.
Right. Okay. So the first question from Steve McWilliam. Do you use subterranean pitfalls in river shingle habitats?
I haven't tried them in river shingles, but largely because of the sort of raising of the water level in the rivers, so you lose your sample. But I have tried them in coastal shingle. So what you do, you get a drain pipe and you drill lots of holes in the drain pipe. So it looks like the outer cover of one of those 18 machine guns, if you want a sort of comparison. And you sink it down into the shingle, and then you put a pot, a sort of, I wonder if I've got one. I haven't got one to hand, but like a screw top bottle, and you cut some slits in the side. And then I found that if you get that brush tape that you put around doors, you can form a snug fit into the tube. And then you get a long piece of broom handle, wooden broom handle, and you attach the lid of the container, screw lid, onto it. So you can actually lower the trap down to the bottom of this drain pipe, and then unscrew it once it's in place, and then leave it, and then cap it off at the top. And what that's doing is all the spiders that are moving in the little spaces between the shingle, they'll intercept the drain pipe, go in through the hole, and then fall down into your catching bottle at the bottom. And then you can come 2 or 3 months later, put your pole down, screw the lid back on, and then pull it out, leaving it intact, the tube, and then empty it and then recharge it. And I found that using, let's see, let me get this right. It's propylene glycol rather than ethylene glycol. So ethylene glycol, I think I'm right, that's the antifreeze for cars. It's also quite toxic. So, but propylene glycol is food grade. So I prefer to use that. And I found that in winter, you can use that for two months and it preserves material fine. And because it's food grade, far nicer to use in the environment. You're not worried if you spill a little bit and what have you. So yeah, I found them very useful. I've turned up other spider records that are new to Anglesey doing that, and things that I would find it very difficult to find otherwise. And I do have some out in some of the slate waste heaps looking for subterranean things, but yeah, so far, no. But yeah, I've got hope that one day some of these subterranean money spiders will turn up in these traps.
Thank you. Yeah, no, I was just thinking, the one, someone that I used to work with in Cumbria, Steve Hewitt, he did actually put pitfall traps in river shingle habitat. Okay. I remember him turning up a rare Staphylinid beetle. I can't remember the name of it now. Something Newbury, I think. And that yeah, it hadn't, they were struggling to find it by hand, and it hadn't been seen for 100 years or something like that in Cumbria. But maybe in the summer months when the I know he has lost different types of traps when doing sort of different emergence traps for dipterans and things, but yeah, I think it's possible. It's a period of the river's not running high, but
I've got another type of pitfall trap that I use. So I've got a big slate slab and I've cut it up with an angle grinder with a diamond cutting wheel into squares, and then I've got one of those diamond coring bits and drilled a big hole through the piece of slate, so it actually accommodates a pitfall trap, sort of a cup. So it'll actually sit within the slate, and then you actually put that into shingle or gravel beds. And because that's allowing the invertebrates to climb from rock, from the shingle onto the slate, and then into the trap. So it sort of, it seems to work quite well. I've had quite a lot of things that way. It's because if you were to just sink a trap in, you've got a lot of gaps between the trap and the actual shingle, and things fall in. Whereas that way, you're actually giving a rock surface for things to walk into. And then you get one of those terracotta plant dishes and put it over the top just to keep the rain out and keep mammals out and what have you. And then you can cut little channels to sort of guide things into the slate. So yeah, it seems to work best for catching centipedes, strangely enough. But yeah, lots of things to think about with pitfall traps, certainly.
yeah. Okay, thank you. Okay, next question from Alan Can. Great photos, Richard. Your preserve spiders look quite relaxed, as legs not contracted. How have they been treated, please?
Okay, well, some of those spiders are quite fresh, so I've actually taken the photos pretty much the day or the day after I collected them. So some of the more spread ones are like that. Some of the rarer ones were obviously preserved a long time ago. And you'll notice that they naturally do this. The muscles contract and the legs do that. There's no real way to unrelax them, I don't think. But there was an older arachnologist called Latouche, whose collection's now in Manchester Museum, and he seemed to actually set out every spider he collected. So when he'd collect them, he had these little oval cards of varying sizes, and he would hook the spider's tarsi around the edge of the oval card, and then put it in the alcohol so that the spider would actually set out like that. And I don't know how he had the time, because you go to his collection and every single specimen is like that, perfectly like a pinned entomological insect with all the legs splayed out perfectly. So if you've got the time, that's what you could do. Or I think just photograph them on the day. That's the easiest way to get the splayed legs. But to be honest with you, it doesn't really matter. It's the legs themselves aren't the nice bit to photograph, I find. I've seen Alan's photographs, they're fantastic, and I can't match what he takes for palps and epigynes. He's got wonderful images of that. But yeah, those whole body shots are great. It sort of gives you a search image in the field as well. You know what to look for. So when you're doing those surveys for some of those rare species, if you know what you're looking for, it does help, because you think, oh yeah, the red and black one I'm looking for. Oh yes, there it is in the tray. I've got to pick up every single one of those I find just to make sure I find it.
Okay, thanks, Richard. I'll go to a question from Dennis now. I'm curious to know which lenses were used for the close-up specimen photographs. So,
yeah. Ooh, giving away my secrets here. They're actually not microscope photographs, strangely enough. They're image stacked using the MP65, MPE 65. It's a Canon lens, so it's a ×1 to ×5, and I think I've got an extension tube on that. But the critical thing is to set your aperture to the sharpest point of that lens. So I think in that case it's 5.6. So set your lens to that. but you'll also need a stacking rail. So I've got one of these stack shot rails, and they're composite images from 20 stacked top to bottom, and then just fire away. It automatically takes all 20 images, and then you just merge them using software like Helicon or Zerine, and then it just stacks all those individual images into one image, and then you've got the full depth of field of that small spider. It's another subject in its entirety, but it's taken me a long time to actually almost perfect that for whole body images. But you can start attaching microscope, sort of slide microscope geological lenses to the front of normal camera lenses to get ultra macro. So you're then getting into the realms of taking images of palps and epigynes. But in that magnification, your physical presence in the room is enough to create camera shake that blurs the image. So I'm still working around this, and you've got to have really stable rigs. So I've got this aluminium rig that I've bought from China, which is purposely made for macro stacking. And it's a sort of vertical rig. So all it is, it's a mirrorless SLR camera I've got. So it's a high megapixels. So you're gaining a bit of magnification so you can zoom in. But yeah, that resolution is all the thing. And yeah, I was quite surprised how sharp they are. And that's because you're putting it to f5.6, but obviously that gives you a very small depth of field. So it's like a seesaw. So if you whacked your camera lens up to f16, you'd get it in focus right the way through, but it wouldn't be as sharp. It would be sort of fuzzy and blurred. So you just got to play with the kit you've got, really, and see what you can do. And I think it works. And Alan Can's got some fantastic things that he does the same, but down a microscope, I believe. And yeah, and have a look online. There's lots of resources that will tell you about image stacking, but that's the secret, essentially, to get sharp images of small objects.
Thanks, Richard. And Dennis, we have a similar setup to Richard by the sounds of it at the museum. So I don't know if you're local, but when we're able to welcome visitors again, you'd be very welcome to come and have a play with it.
There's these LED spotlights as well that you can buy online, and they're great because you don't have to use flash, and they're quite nice color temperature as well. So I haven't done any color correction to those, and I'm happy with the actual image. They do actually look like the color of the spider. So they're sort of gooseneck things, and they're only something like 20, 30 quid a piece. So really cheap for microscope lighting, really.
Well, thank you very much. Those are great answers.
Okay, thank you.
Okay, we'll go on to a question from Stephen Wilson. I'll read all of this out because it's nice. So you have converted me. My old flatmate from university was an arachnologist at Bristol, then Oxford. Any suggestions on how to go about getting a decent stereo microscope? I now live in the East Anglian Broads and cannot wait to get out and focus on spiders. Fen raft spiders are our local speciality. I realise this is not a money spider. So microscopes.
Okay, well, actually you're lucky because microscopes have got a lot cheaper, sort of reasonable microscopes. So you can get something reasonable for about £250. Or okay, it's not top of the range. If you go into the museum and play with some of their kit, you'll suddenly realise how poor your optics are on your microscopes. But I think somebody once said, get the best microscope that you can afford. So that's always the way with microscopes. The more you spend, the better the optics. It's a fact of life, isn't it? But there are some nice Chinese microscopes that are really affordable. The optics really good for the money. And yeah, Brunel microscopes, they do some nice entry-level scopes. I can't remember the model, but there's one with a carry handle on the top there.
SX10s, I think.
Yeah, you've got some there at the museum, Gary. And they're great for the money, actually, if you're just starting out and don't want to splash several thousand, because you can very easily spend multiple thousands on a microscope, and if you don't really get into it, it's money wasted. But the thing is, buy a good microscope. If you want to continue it for decades, get the best microscope you can afford, because you don't want to be struggling with really poor quality optics, because let's face it, your eyes are precious, and you will ruin your eyesight if you're struggling with poor optics and doing a lot of microscope work. So get something really good. If you can afford it, you can't go far wrong with Leica. And think about second-hand microscopes. Okay, you won't get all the fancy trinocular attachments, or you'll find it difficult to attach a camera. But if you're only wanting to use it for microscopy work, some of the old Zeiss's image quality, superb, and you can pick these up for a couple of £100, and they're probably, for the money, brilliant entry level, and often they're quite small, compact microscopes too. So look out for things like that. I know there's Brunel have a second-hand section of microscopes. Have a look through them. Get on the phone to them and say, I'm looking out for a nice microscope, stereo microscope for doing entomology, and they may just say, yeah, I've got an X demo model that's 50% of the original price or something like that. So try that. That's a good tip. And some of the eBay microscopes that you can buy from China, I've seen some of them that people have used, and they're good, but obviously you're taking a risk there because you don't know the make, you don't know the image quality. But the ones I've seen, people have got £200 microscopes, and for the money, they're brilliant.
And Richard, you wouldn't want to go for money spiders. You wouldn't want to have a magnification, a maximum magnification of less than ×40.
Well, really, I use in the range of ×20 to ×40 for ID. Now, okay, you're struggling to see the detail on the really, really small ones, but generally you're not going to be coming across those really, really small ones too often. They do say up to ×90, but the depth of field at ×90 is so minuscule that it's not really useful. So ideally, I would say probably ×50 to ×20 if you can get it, but most entry-level microscopes are in that range of ×10 up to ×40. They tend not to go beyond ×40 unless you're putting supplemental objectives and different eyepieces in, but I wouldn't bother trying to upgrade. I know Leica do a ×80, which is quite a nice scope, and I think that comes up on eBay secondhand. But with secondhand microscopes, you also have to watch out for fungal optics, because sometimes they're things that have been used in commercial labs and have been hammered to death. So the actual internal workings might be shot to pieces, and the lenses may be fungus. And if you're not actually examining it before you buy it, you could come a cropper. So yeah, I think probably my best suggestion is go via Brunel, and at least you know you'll get something usable and affordable. And because you can buy sort of very cheap microscopes that have got plastic lenses, and to be honest with you, they're just not worth the money. You might as well put that money towards something better and get it next year, for instance. Some places lend microscopes as well. So I know the record centre I work for loans out microscopes to people just if they want to try doing some ID work. So there may be similar schemes in your area. So ask your local record centre, ask at a local museum. If they, in non-COVID times, you might be able to pop into the museum and use their equipment. So do that.
Thanks, Richard. That's really, really sound advice there. Okay, onto a question from Kirk Mason. Do you think the differences in the gibbosus head morphology are a potential snapshot of speciation taking place?
Difficult one. I suppose it's not really in that case, because what they say is like Mendel's peas. It's that dominant recessive gene. So if you've got, let me get this right. I'm trying to go back to my biology A level now. So the dominant one, if you get a heterozygous, if you know what I'm on about, to get the tuberosus one, you need 2 of the recessive genes to show a tuberosus male. But to get the gibbosus with the hole in the head, you either need it heterozygous, so dominant gene and a recessive gene, or 2 dominant genes. So it's actually the same population, just in that it's preserved simply because there's a competitive advantage with the males feeding or not. But yeah, I suppose these things could eventually lead to separate species, but it's that lock and key with the palp. So that if it's sort of controlling the courtship and there's changes in the head structure, and maybe certain females will only mate with certain males and not the other, it could essentially split off into 2 species if there's no gene exchange. But at the moment in that gibbosus, it is a sort of happening within that one species, and the genes are exchanging between the 2 forms of the male. So it's not going to lead to speciation anytime soon. But yeah, it could do in other examples, particularly if it's changes to the epigyne structure and the palp structure. Because it's a lock and key system, you could very easily change the shape and it splits into 2 different lineages.
Alan Cam was just also mentioning on the topic of microscopes, GT Vision are also good. Phone them and ask about used microscopes.
Yeah, good point. Thanks, Alan.
And Steve was just asking about perhaps a separate session on stacking alone. So
try. Yeah.
We are thinking about equipment related sort of webinars.
Yeah, there's also a tip with actually putting the spiders in for stacking. So you use alcohol hand gel. At one point last year, it was very difficult to get hold of, but I think you can get it now. So it's that clear alcohol hand gel. So put a layer of that in a glass, small petri dish, or those excavated glass blocks. Put your spider in and then put a layer of alcohol over the top. And then what you can do is embed it at different angles. So you're not having to hold it in place with the glass beads. And you can also put one of those, what they call them, light boxes. They're like LED light boxes, like wafer thin things. And you can put coloured acetates underneath. So you can have a nice blue background or whatever colour you like background. And it just isolates it and makes it look a bit more cleaner as an image. So, because otherwise, if you've just got the spider floating around in alcohol, you get these Brownian motion that will just move the spider around, and it will ruin your stack because the spider will be in a different plane of view and the software won't be able to interpret it properly. Problem with the alcohol hand gel is that you have to wash it off the specimen afterwards, because although it's alcohol based, it has glycerine in and what have you. And what I've found is that it leaves a colloidal material on your specimen. So what I'll do is, after I've photographed it, take it out, wash it in alcohol with jets from a pipette, clean alcohol, just to clean off that alcohol gel, or put it in a tube of fresh ethanol or what have you, and shake it up and down just to wash it off. So I've read in some cases that some of it does dissolve off in some brands, but I don't know what brand they were using. Maybe it's a different one.
Yeah. Oh, just a quick question from Dennis. It's just come in there. Are there any interesting frontiers of spider research you're exploring, Richard?
Not so much myself. I suppose my main research tends to be taxonomy of African transler spiders, but that's sort of been put on the back burner at the moment. But I'm sort of working slowly towards a few more papers on that. But if you want to do some ecology work on British spiders, there's so much that we don't know about them. Sort of even the egg sacs that they construct, we don't know what the shape of a lot of these egg sacs are. So you could easily break new ground by simply collecting a few money spiders, keeping them in captivity, photographing the egg sac. And of course, then there's the DNA barcoding. You could actually find egg sacs, photograph them, DNA barcode them to find out what species created them. And you're building up a new resource, because some of it, I assumed that a lot of the money spider egg sacs all look the same. And then I started noticing that you get some that are fixed flat to rocks, some that are cocoons within the egg, within the web itself, some that make multiple ones, some that sit next to them, some that just lay them and leave them. So there's all sorts going on there that is probably very under-recorded. And a lot of the ecology of these spiders is just unknown. We're only really scratching the surface. We know where we find them simply because we find them. We don't often know what the microhabitat is. So going back to that Paracymbium gowerense that I showed you, I got that contract because this spider had been found back in the 80s on the Anglesey Fens in sort of pitfall traps. Of course, pitfall trap doesn't tell you what the microhabitat of the spider was. It just tells you that it happened to be walking around in that area at that point in time. Now, I had to sort of focus in on all the different microhabitats on those fens to actually pinpoint what microhabitat it was living in. And I sort of surmised that a rare spider must be living in a rare microhabitat, that otherwise it'd be everywhere. And found these genus flushers, these black bog rush flushers. And sure enough, when I started investigating these thick black bog rush flushers, there was the spider. So it wasn't throughout the fen, it was just on these flushers. And it's a strange one because it also lives in Saltmarsh on Juncus maritimus. And it seems to be that structure of the tussock that it likes, this large, thick tussock, rather than just any old genus. So grazed genus wouldn't be suitable. Saltmarsh, grazed flat, unsuitable. So you're sort of honing in what the ecology of these species is, but that's just one species, and only because NRW had money to throw at it because it was a rare species. But there's loads of common things out there that we don't know how they live really. We're just scratching the surface. So plenty of opportunities for research really.
I've found that there's been a lot of money spiders that set up their station on pitfall traps to catch other stuff falling in. They're very sneaky.
Yeah. Well, I say they often like those rabbit scrapings, you know, in grassland where the rabbit has scraped a little hollow and put a few turds in the bottom or what have you. And you'll often find the web stretched across it in that recess there. So, yeah, they're always looking out for opportunities and gaps to fill.
Excellent. So there you go, Dennis. There's plenty that we don't know, even about common species, to research in the UK. Okay,
Yeah,
well, thanks, Dennis. Well, I think we'll leave it there then. But there we go. Excellent introduction for you to really get inspired and get into having a go at money spiders and getting all the right equipment if you really want to get serious about it. And
thanks for the opportunity to talk about them. Actually, it's quite a niche bit of spiders really. A lot of people don't talk about money spiders. They're sort of pushed to one side, so it's good to try and enthuse people about them really and take a second look. And obviously you don't have to try and identify all 280 odd species, but just look out for those common easy ones and your interest will grow, because they are such a diverse group, and with those strange male heads that are going on there, it's fascinating. And there's some of those that I haven't found that I'd love to find, and things that are only found in the south of England that just don't occur up here. And maybe as things warm up, we might see these things moving north, and the distribution of these things is quite fluid. So you will see things that were essentially south coast specialities gradually moving up into northern Britain. So plenty to do in Cheshire. There are things turning up in Cheshire in the south there that weren't there 20 years ago, spider-wise. So yeah, watch this space. Things are changing. It's not a static group of spiders anymore. It's got the potential to move huge distances with ballooning too. So that American species I was telling you about, Myrmesis trilobatus, that's going to turn up soon. You could be the first one to find it. So get out and look for it. In 30 years' time, it's going to be everywhere.
Brilliant. Thank you so much, Richard. And yeah, have a really good rest of your afternoon, everybody, and weekend.